Hey, what's up guys? So in this video I'm going to talk about the Ultimate Arduino Programmer Board. Okay, so I'm kind of getting that mixed up a little bit. In my last video I talked about the Ultimate Prototype Board. Well, in this video I'm going to show you how the Programmer Board works, why I think it's ultimate and why it's different than all of the other USB to serial converter boards out there, and how to assemble the kit. Okay, so let's take a closer look at what I got going on here. Okay, so this is what a fully assembled programmer board looks like, okay, with all the headers soldered on. And right after I explain how this board works and all the features, I'll actually assemble a board in real time, so you can watch me solder all of the headers onto the board, and I'll give you a few tips and tricks on how to get the headers on the board and all that. So stay tuned for that. But the board is based on an FTDI IC, the FT232RL. So when you plug this into a PC, it comes up as a virtual COM port. So, you know, in your Arduino IDE, when you go down and select the serial port, you'll see whatever the next COM port is in the list. So like it could be like COM 33 or whatever's next, okay? And on the Mac, it's the same thing. You plug it in, and it comes up as some serial device, and that's what you would select for programming. So obviously, I designed the board to work with the Ultimate Arduino Prototype Board, and it plugs in to this board very easily via a 6-pin programming header. Okay. So that's how it works with this, and this is the same pinout as the Arduino Programmer, I believe, and that's something I haven't tested out, compatibility. So with the prototype board, I only program it with my own homebrew programmer board here. So that's something I'm looking for feedback on to see the compatibility. Like, will this program Arduino's, and can this be programmed by the same equivalent board that Arduino has? Okay, so let's go over a couple of the features here. So the thing is riddled with jumpers, and it plugs into your computer via a full-size, heavy-duty USB port here. So I chose the full-size, not a mini, not a micro, because I have experienced those ripping right off the board. So this thing is heavy-duty. You can throw this in your bag, and you'll be good to go. So you have the full-size USB connector here, and you have 3 LEDs on the board, one for the TX, RX, and a power on LED, which is very useful. And let me give you an example of why that LED is useful. So if you have something big, a big project that pulls a lot of juice, well, if you plug this into that project, you would not want your USB port sourcing the power for that project. So on here, I have a jumper for power. So you can either be sourcing power from this, so you would put it in the power on position, or turn the power off. And this LED indicates whether or not this is sourcing power. So in the case of an LED cube, like my big giant LED cube, I would not want to be sourcing power off the USB port. So I would have this jumper in the off position, and there's some nice silkscreen text on there so you know which position is which and which jumper is which. And I would have this in the off position, the LED would be off, but I could still program the cube because the grounds are still tied together. It just will not source any power, okay? So that's kind of handy. In fact, I'm going to plug it in real quick just to show you that. Okay, if I plug it in right now, the jumper is in the off position. So if I put that jumper in the on position, you'll see the green LED comes on. So now it is sourcing either 5 volts or 3.3 volts. Okay, so the other jumper here selects between the two voltages. So I have it set right now for 5 volts, but if I were let me unplug it. I should probably do this while it's unplugged. So if I put the jumper in the 3.3 volt position, now what it sources is 3.3 volts, and the I/O, or the voltage level of the IC, is set for 3.3 volts. So your logic levels are set for 3.3 volts. That's what I'm trying to say. Okay, so that's the operation of the two jumpers. Now I just want to show you a couple things with the headers. So you have the 6-pin right angle header, which fits and works very nicely with the prototype board, but you also have breadboard headers. So if I take a breadboard like this, I can plug it right down into a breadboard and have my standalone Arduino out here, and I could jumper wires over and just carry around my breadboard like this. So it's a perfect programmer for a standalone Arduino, and I use this all the time for that. The other thing is there is a female header on top here that works nicely with jumper wires. So if you had something kind of already permanently set up in a system and you just want to kind of tap into it, well, I have female headers set up on top so that you can go and connect into whatever circuit you might have. So it's just a kind of a handy way, or you can use this maybe just to get 5 volts or 3.3 volts off the board. So that's why I have that header. Of course, you could also use the right angle header for that as well, but the header on top is just for convenience. And obviously there is silk screening everywhere letting you know what is what, so you never have to pull the data sheet for this thing. So that's one of the nicest features about this board. So that is the Ultimate Programmer board. Now let's actually build one. Okay, so let's go ahead and get the build started here. And the way you will receive the board, it comes with all of the surface mount soldering completed. Okay, I actually used my Arduino controlled reflow oven to do this soldering, and I did have to solder on the USB connector here so that I could fully test the board out. And each board is tested. The only quality issue with the boards is on some of the boards the LEDs are placed incorrectly. So there's 2 color LEDs here. You have orange LEDs for the TX and RX, and there should be a green LED for the power on LED. And some boards, these were switched around. So you may have all red LEDs, you might have a kind of a mix. So it's not really a big deal. The board still works perfectly fine. It's just something I need to correct in my quality department. So anyway, we can get started building here. The tools you'll need are the same tools we used on the prototype board. So, you know, wire cutters, long nose or needle nose pliers, not needed but could help in some situations. You will need, obviously you need solder and a soldering iron with a fine tip on it. For this board, you don't necessarily need the finest tip soldering iron, but if you got through the prototype board with whatever soldering iron you used for that, same should work here. No difference. The only thing I can't find here that you might need is solder braid or solder wick, but that's only if you screw up. So anyway, I don't need to show you that, so we can go ahead and get started here. And again, with this board, you don't need to place every component. It's, you know, if you know you're not ever going to be using it in a breadboard type manner where you plug into the breadboard, then don't solder those headers. If you know you're only going to program it via to the prototype board through the right angle connector, then really that's the only programming header you should solder to the board. Okay, so that's up to you. But in this demo, I'm going to solder all of the components to the board. Okay, obviously you will need both the power selection and power on jumpers and headers. You do need those. But the actual programming headers, those are optional depending on how you use the board. So I'm going to go ahead and just jump right in. Let's just pick one here. Let's pick the 2 breadboard headers. So there's a 5-pin header. I think that's 5-pin, yep. And that goes on the bottom of the board like this. And to help do this, because you do want this to line up with a breadboard, so one way to make this a little easier on yourself is drop both of these in and then actually plug them into a breadboard. Okay, So I have them both in a breadboard like this, and that fits really nicely. Okay, now you gotta be really, really careful here. If you're gonna be soldering while you have something plugged into your breadboard, there's a chance that you could melt your breadboard and damage it. So do not apply a lot of heat for a long period of time to any of the pins. I'll show you how I'm doing this here. The way I'm gonna do it is just very lightly give it a little bit of heat and solder until the joint starts. Okay, and then release the soldering iron away, and I'm going to do the same thing. And I think what I'm going to try to do here is just do one pin on both sides, and now I can remove it, and the breadboard survived just fine. So now it's good. Now the pins, the headers are held to the board pretty securely, and I can finish off the rest of the header here. Okay, so I'm going to go through and solder those real quick. Okay, do the 4-pin. The pins that are connected to ground are going to need a little bit more heat because they connect into ground planes on the PCB. So that's going to be pulling a lot of heat away from the soldered joint. So that's why you need a little bit more heat there. Okay, and that's done. Now I'm going to give it a quick test here. And it plugs in perfectly to the breadboard. So that's cool. Alright, next let's do the right angle female header. And before you solder this one on, you might want to just check it out, make sure it plugs into your board. Yeah, okay, everything looks good. This is actually the first time I'm assembling this board, so I'm kind of discovering things as I go along here as well. Okay, so for this one, what I'm gonna do is try my old technique, which is put a little bit of, get like a solder ball going on the tip here of the iron, and then with my fingers I'm actually going to squeeze the header onto the board so it sits flush, and then kind of just dab it on one of the joints until I got just a clump of solder on one of the pins, okay, just to hold it in place. And then I can go back now and solder the rest of the pins. Okay, clean my tip off, get all that crap off it, and I'll go right on through here. And clean up that one joint that had extra solder on it. Okay, so that is the header, the female header that would program the ultimate Arduino prototype board, and that fits awesome. So that fits perfectly. You see, so this is why you might not want to solder the breadboard headers here, because if this is sitting flush, these are touching the bench here. So if you didn't have those, you know, it might kind of sit a little nicer, I guess. But you know, obviously you wouldn't want to lay the prototype board on a metallic surface or a conductive surface, because you know you do have a lot of live connections on the bottom of this board that would be shorted out. So, but anyway, I'm rambling, so let's keep going here. I'm gonna do the 5-pin female header here now, the vertical female header next, and for this I'm gonna have to use, I don't have to use my technique because I can kind of push the board down on it. So for this I'm just going to, actually if I just rest it like that, it's holding it in place perfectly. So that'll work for me. Alright, let's get one on there before it slips. Okay, that one on. Okay, those look good. One more. Okay, those joints look awesome. Give it a quick test, see how that, okay, good. So next we'll do the I don't know where that header came from. Next, we'll do the 2 3-pin jumper headers. For these, I think, yeah, I might be able to just kind of balance it. No, I'm going to do the clump technique. So I'm going to get a little ball of solder on the tip here. And I'm going to kind of hold the header. These are a little bit harder to manage. And I'm going to just get, oops. And I think I mentioned in my in the build video for the prototype board to not apply heat to the header that you're touching with your finger, because you will burn yourself. Okay, yeah, that's okay. Let's get a little straighter. Okay, that's better. But you could see how bad that joint looks. It's like a big teepee of solder on top of there. Okay, but now I can go back in. I'll do the other joints real quick, and then now I'll clean this one up. Perfect. Hit the soldering iron, dump it into my brass sponge here, get all that extra solder off it, and now we can do the next header. Okay, we'll get this guy in there, and let me get a clump of solder on here. Okay. And I'm going to do the same technique as before. It's going to be a little tricky to do. Just make sure it's sitting flat and straight and not touching my finger. Nice. Okay, we got it. So there's some actual bridging going on there. I put so much solder on when I was doing the clump technique that it actually bridged over to the other joint. So it's really important that you check your joints and make sure there's no solder bridges. Okay, everything looks really good here. So that is it for the soldering. Now I can actually place the jumpers, and I'm gonna set the one for 5 volts and the other one for power on, so it does deliver power to the board. Then you're going to want to grab a meter and check to make sure that you do not have any shorts from 5 volts to ground. Oops, making a mess over here. I just want to make sure of this real quick. So let's do set this up for continuity real quick. Okay, that's good. And I'm gonna just go ahead and go right across VCC and ground. Okay, so we're good. There's no shorts, no beeping. Okay. Now next, what I'm gonna do is actually test the board out. Let's see if this will take a sketch. So let's plug that in, and I'll have information as far as setting this up. Once you plug it into your computer, it should set up just like a USB. Sorry, I'm doing a whole bunch of things here. As soon as you plug it into either your Mac or your PC, the drivers should automatically install. But if they don't, I'll have links in the description to where you can get the FTDI driver. And I'll have resources as well, some links to some different troubleshooting resources in case you have any issues getting everything installed properly. Okay, so when we have power applied to the board, you can see that the green LED is on. Now I'm going to open up the Arduino IDE on the computer. I'll go to Tools, I'll go to Serial Port, I'll select the USB to serial converter. And then I'm gonna go ahead and open up the example sketch real quick here, blink without delay, and see if it will take a sketch. Okay, you can see the TX and RX LEDs lighting up. And it did indeed take the sketch, because this is connected to digital pin 13 and just driving an LED, and it's just turning it on and off. And I've changed the time, the on and off time there, so that I know that it did work. You can see that the power switch does nothing in this case, since the programmer is applying power. So that's pretty much it. So I hope this all works out for you. Thanks for watching.